Please close your mics. Please close your mics. Mute your mics.
Yes, yes.
Guys,
done. Where you buy?
Quinda, please.
Yeah. I'm closing. I'm closing.
Quinda, please.
I have a network problem. Sorry, sorry, Sepo.
Please close your mic. Is it muted now? Okay, I think it's muted. Good day, guys. Welcome to this session. So today I will be doing mathematics, analytical geometry, and I will also send some of these questions in WhatsApp group. So now today we're gonna do problem solving, and then remember, meanwhile I do problem solving, I will also do some touch-ups on the basics of this content. So I still hope you guys are able to hear me. Please just say yes, I am able to hear you if you are able to hear me. Hello? Is everything loud and clear? Can you see on the board?
Yes.
Okay, all right.
Yes, you can see.
Oh, you can see, all right. Okay, that's what I wanted to check. Okay, so now let's start, guys. Like I said, I'm gonna do problem solving, and then meanwhile I do problem solving, I'll try to do as well. This thing is, I'll try to do the, let me choose the pen, the black pen. I'll try to explain some of the basics based on these questions. So now let us start with question number 3. So now question number 3, it reads as follows. It says to us in the diagram below, line AB makes an angle of beta with x-axis, and line CD makes an angle of alpha with the x-axis. A and D are points on the x-axis. The coordinates of B are given to be √3:t. AB and CD intersect at E, which is at this point. A point on the y-axis and A angle ED is equals to 63.69 degrees. The equation of CD is provided to be 3x plus 2y is equals to 6. Okay, so now before I can commence with the questions, guys, this is what is happening. When you talk about the analytical geometry, you're supposed to understand the basics, okay? How to determine the equation of straight lines, the properties of your quadrilaterals. You've learned about the parallelograms, you've learned about the rhombus, you've learned about the square, all of different types of quadrilaterals. You're supposed to know their properties, because in Euclidean, in analytical geometry, you are also tasked to apply those basics. And then again, this is what is happening. Know your distance formula. Know your midpoint formula when you get into this topic. And then again, know how to determine the angle given the gradient of a certain line. So now I'm going to do the questions, which is question number 3.1. Now 3.1, it reads as follows. It says to us, determine the coordinates of E for 2 marks. So now let's go back to our diagram to locate E. Here is E located. They want us to determine the coordinates of E, okay? Yeah. So that means we're gonna do a 3.1, okay? We're gonna determine the coordinates of E. So now this is what is happening. We were given this straight line, which is called line CD. We were given the equation. We are actually given the equation. So the equation of the straight line CD is given to be what? Is given to be 3x, okay, plus 2y, don't mind my writing, is equals to 6. Now, this is what is happening. The straight line of CD, it is not given in a what? In a standard form. That means we're going to have to rewrite the equation of CD in a standard form first. So remember, what is the standard form? The standard form is given to be y of a linear function. Y is equals to mx plus c. This is the standard form of a linear function. That means this equation, we're going to write it in this form. So now how are you going to write it? We're going to say, we're going to make y subject of the formula. We're going to have 2y is equals to, I'm going to transpose 3x to the other side of the equation, negative 3x plus 6. And therefore, I divide both sides by 2. Y in this case is equals to negative 3 over 2 multiplied by x plus, what is 3 divided by 2? It's going to be positive 3. And therefore, now this is the equation of CD in a standard form. But the question here to us, it said to us, determine the coordinates of E. Now, in order for us to determine the coordinates of E, the equation of CD, it passes through point E. Now, E in this case, it is what we call y-intercept. So we know that if E it is y-intercept, we know that for coordinates of E, the value of x in that case is going to be 0 because it is the y-intercept. E is a point which is called y-intercept. And therefore, what will be the value of y of this coordinate, which is point E? The value of I will be y-intercept of the equation CD. Remember, one of the reasons why I wanted us to write the equation of CD in a standard form is because I wanted us to determine the y-intercept. C, remember, it represents y-intercept on our Cartesian plane. That means this equation of CD, it passes through positive 3, which is y-intercept of the equation. Therefore, point E, it is also y-intercept. Therefore, the y value of E in this case is going to be positive 3. And therefore, this is the final answer, whereby the question wanted us to determine the coordinates of E. Okay, I hope we all understand how to solve this question. Right. Any question before I move on? All right. So that means I'm going to do 3.2. Okay, 3.2. Now, 3.2, it says to us for 2 marks again, determine the gradient of CD. You go back to your diagram. You're going to look for what? Or remember, we have already determined the coordinates of E is, let's just, for in case, we have just determined the coordinates of E to be 0, is to, I think, is to 3. Yeah, is to 3. We have determined this. Maybe if we're going to need it, let's just write it there. So 3.2, it says to us, determine the gradient of CD. So now where is CD? The very same line that we have just talked about, okay? The very same line that we have just talked about. I'm going back a little bit of where we started. So now, in order for us to determine the gradient of CD, remember I taught you phase of gradients. I don't know if you guys in grade 10 last year, no, I didn't teach you maths. Now, this is what I call phase of gradient. Let me teach you this. So this is what I call phase of gradients, okay? So here we have this slope, we have this slope, we have this slope, and then we also have that slope. So I call this phase of gradient Mr. Biki, okay? I call it Mr. Biki. It's called the phase of gradient. This is my phase of gradient. So phase of gradients, these are linear functions. You have to know what is the sign of this gradient, what is the sign of this gradient, and then the sign of the remaining gradients. Now, this is what is happening when mathematically, even in physics, this is what you're supposed to understand, okay? So if you have if you have a Cartesian plane like this, and then you have a line that moves from this position to that position. Let's say again, you have a Cartesian plane, and then you have a line that moves from this position to that position. Let's say once more, again, you have your Cartesian plane, you have a line that moves on a straight line. Let's say again, you have your Cartesian plane, and then you have a line that moves like this. So now a line that moves like this, it moves down the slope, starting from the y-axis, it moves down the slope, meaning we're talking about the negative gradient. A line that moves from this position to that position, starting from the y-axis, we say this moving up the slope, it is positive, meaning here we're talking about a positive gradient. And therefore here, you can't move moving upwards or downwards. That's impossible, guys. You can't move vertically. You can't move upwards. You can't move downwards. There is literally ground if you want to move downwards. So that means the gradient of this line, we say it is undefined, okay? We say it is undefined. And therefore here we are talking about zero gradient because you will be moving on a straight line. So here we have a negative gradient, and then here we have a positive gradient, and then here we have a undefined, and then here we have 0. So this is a phase of gradient. So they say to us, determine the gradient of CD. CD most definitely supposed to have a negative gradient, because I have just showed you when you move down the slope, we are talking about the negative gradient. So CD is moving down the slope. In order for us to determine the gradient of CD, we are not given the points. We are not given point C. Yes, we know point E. We are not given point D. So we can't use 2 points to determine the gradient. We know the equation or the formula on how to determine the gradient. But in this case, we can't use that. So now what are we going to use to determine the gradient of this line? Remember, we were given the equation of line CD. We were given that literally, and then we wrote that equation in a standard form. And then remember, M on your linear function, it represents your gradient. So that means in this case, M, which is the coefficient of X, our gradient in this case for 3.2, which is the gradient of CD, is going to be -3/2. Why this gradient is negative? Because it is a decreasing gradient. It moves down the slope, okay? So that means for this question, which is 3.2, I'm going to say the gradient of CD in this case is equals to how much? Is equals to -3/2. That's how you answer question number 3.2. So what I do, guys, is I try to elaborate on the basics before I can give you the solutions. So I hope you all understand why am I moving like this. So this will be number 3.2. Okay. So do you all understand? Can I get yes or no? Participants?
Yes.
All right. So that means you hear me. Right. So
Yes.
all right. I'm gonna move to the following question, the next question, which is 3.3. Now 3.3, it says to us, calculate the value of alpha. So that means we want to determine the magnitude of this angle. So this angle, it is called angle alpha. We want to determine its magnitude, okay? So now how are we going to determine the magnitude of that alpha? Okay. How are we going to determine the magnitude of alpha? Let's have a look at it. Now, alpha, like I said, it is this angle. Usually, now this is what is happening, guys. This is what I want you to understand before we can solve this question, okay? Let's talk about the basic, as much as I love doing that. So let's say you have a Cartesian plane like this, okay? You are given your Cartesian plane, you have your y-axis there, and then you have your x-axis there, okay? And therefore, let's say you have a line that passes on your Cartesian plane, and let's say you are tasked to determine the magnitude of this angle. So this angle over here, I'll just call it angle theta. They say to you, determine the magnitude of angle theta. And in that case, you are given the gradient of this line. So I'll call this line AB, okay? And they say to you, determine the angle beta, which is this angle, which is the line, which is the angle that is found between x-axis and the line of AB. Usually, mathematically, this is how we determine the angle. You're going to use the gradient of this line to determine this angle. Meaning, now this is what is happening. This is the problem where it starts, okay? I call this angle, I say this angle is angle theta. So I know some of you, you're going to say tan theta is equals to gradient of AB. So let's say the gradient of AB, it is given, and therefore you're going to say theta is equals to second function of tan, and then you include your gradient, which is line AB, and therefore you're going to get your theta, which is blah, 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 blah. So in this case, your answer will be incorrect. Why your answer will be incorrect? It's because each and every time when you are given a straight line just like this, and therefore they say to you, determine any of the angles, just know that all the time you're supposed to move from positive x-axis moving counterclockwise. So when you determine if you want this angle, let me write it again. So like this. So you're going to have to determine this angle first, okay? I'm going to call this angle alpha. You're going to have to determine this angle first. After determining this angle, you will be able to determine this angle, which is called angle theta, by using sum of angles on a straight line. So each and every time, if you are given the gradient of this line, start from positive x-axis moving counterclockwise. I hope you all understand what I'm saying. So in order for us to solve question number 3.3, they say to us, calculate the value of alpha. And then remember, we know the gradient of this line, which is CD. So that means we're going to say tan alpha in this case, not beta. We're going to say tan alpha in this case is equals to what? Is equals to gradient of line CD. And therefore now, what is the gradient of line CD? It was given to be -3/2. Remember, we have just determined it, I get it? And therefore here we have tan alpha. And therefore I'm going to say my alpha is equals to second function of -3/2. 2. I've heard some of you will be like, why did you include negative number? When it comes to analytical geometry, it's okay if you don't want to include it. But when it comes to analytical geometry, I always include negative number. You're not going to get it wrong, okay? So let's do it. I'm going to show you why I use negative number. So that means in this case, we're going to say alpha is equals to, let me just use my calculator over here. You're going to say second function tan, negative 3 over, what am I doing? Negative 3 over 2. And therefore, I get to 2 decimal places. Why do I get, my calculator, it is in radians. So let me do the degrees. So that means I'm going to say shift second function negative 3 over 2, and then I get negative 56. I get negative 56,31 degrees into 2 decimal places, okay? I get negative 56,31 degrees. Now, for the fact that my angle is negative, each and every time when I see that my angle, it is negative all the time, I include plus 180 degrees so that my angle can be positive. And if I'm going to say negative 56,31 degrees plus 180 degrees, and then I get that my alpha in this case is equals to 123,69 degrees. Now this angle value, it is greater than 90 degrees, but less than 180 degrees. This is an obtuse angle, hence why my angle alpha, it is 123,69 degrees. Therefore, that's how we solve question number 3.3. Do you all understand? Do you all understand? Can I get yes or no?
Yes.
Okay, thank you. All right. So now I'm going to move to the second question, which is 3.4. Okay. 3.4. Okay. So now 3.4, it says to us, hence determine the value of beta. So this is angle beta. We have already determined the magnitude of alpha. Remember that. I get it. So now beta, you can also do the very same procedure of using the gradient of this line. But the problem is we don't know the gradient of line BA. You see, we don't know the gradient of line BA. We were not given the equation of line BA. We don't have point A. We don't have point B, because here, remember, it's T. It's not any number, it's T. We don't know anything about AB. And then how are we going to determine angle beta? So we're not going to use the same approach that we used to determine this. We can, but it's just that we don't have enough information to do that. So how are we going to determine the magnitude of angle beta? So now this is what is happening. I want you to take a note of triangle AED. I don't know why my thing is moving slow. I want you to take note of A, E, and D. Triangle A, E, D. This triangle, this is what is happening. Remember from the information, we were given that A angle ED is equals to 63,69 degrees. Basically, AED, it is this angle, right? The magnitude of this angle was provided to be 63,69 degrees. I don't know if I would be able to write over here. Let me see. Oh, I'm able to write. So the magnitude of this angle is 63,69 degrees. I get it, it is provided. So we're going to use that angle. So that means this angle plus this angle is equal to sum of the opposite exterior angle, meaning some of these two interior angles, when you add them together, they will give, or they will yield to this angle, which is called alpha. So for 3.4, let's determine beta. So that means we're going to say beta plus A angle ED is equals to alpha. Mathematically, we give a reason why that is the case. We're going to say exterior opposite exterior angle of a triangle. This is one of the reasons why we say this is true. Beta plus this angle is equals to alpha. Beta plus this angle is equals to exterior angle. from this triangle. Therefore, we are looking for beta. So I'm going to say beta plus what is the magnitude of this angle? It's 63,69 degrees is equals to alpha. What is the magnitude of alpha? Remember, we said it's 123,69 degrees. We have already determined the magnitude of alpha back then for question number 3.3. And therefore, I'm going to say beta is equals to, we transpose this to the other side of the equation, we subtract. So that means I'm going to say 123,69 subtract 63,69, and therefore we get 60 degrees. So that means beta in this case will be equals to 60 degrees. That will be the numerical value of beta for only 1 mark. Okay, that's how we solve this question. Right. Now we move to question number 3.5. Oh my God, I'm running out of time. Ooh, Zoom. Whew. All right. We will do another session if guys. Let me see. Okay. All right. Now let us move to 3.5. 3.5, it says to us, determine the equation of AB in the form of y is equals to mx plus c. 3.5, determine the equation of AB. AB, it is this line, A to B. A to B, we want the equation of this line. What we know about this line, we know the gradient, right? We know the angle, which is angle beta. We can use this angle to determine the gradient of AB. So that means in order for us to determine the gradient of AB, we're going to say gradient of AB in this case is equals to tan beta, which is the angle of gradient AB, okay, to determine the gradient of this line. Therefore, what is the magnitude of beta? We have just determined beta with 3.5, that it is 60 degrees. And therefore, when you punch this on your calculator, whereby you're going to say times 60, you're going to get root of 3. You're going to get positive root of 3 times 60 degrees. So that means the gradient of AB in this case is equals to root of 3. Now, for a fact that we managed to get the gradient of AB, therefore, remember, AB, it passes through point E, and point E, it is also y-intercept of line AB. So that means for value of C, we know that it is the common number as this one of CD. So that means the value of C in this case, so we're going to say Y, the equation of AB is going to be Y is equals to gradient of AB in this case is given to be, it is calculated to be root of 3 multiplied by X plus Y-intercept, which is the value of C. The value of C, remember, it's the coordinates of E. And how much did we get for coordinates of E? We got, where is it? We got positive, it was 3. It was 3. So that means it's going to be positive 3. So this is the gradient, and this is y-intercept of line AB. Therefore, this is the whole equation of line AB. Do you all understand? Right. Vanessa, please switch off your mic. Mute your mic, Vanessa. Vanessa, thank you. Right. So now we move to 3.6. Now 3.6, it says to us, 3.6, it says to us, calculate the value of T, the numerical value of T. This is the value of T, Y value of point B. It's a Y value of point B. We want numerical value of T. So how are we going to do that? Now we have already determined the equation of AB, right? We said that the equation of AB, is equals to root 3 multiplied by X plus 3. We have already determined the equation of AB. So in order for us to determine the Y value of point B, what are we going to do? We're going to say this equation, which is the equation of AB, it passes through point B, whereby point B, its numerical x value, it is root of 3 is to its y value, it is t, which is what we are basically looking for. Therefore, we're going to substitute everything that we see here onto this equation. Remember, this is a coordinate system whereby this is x and this is y. And therefore, that means onto my equation on the line of AB, my value of y in this case, it's a value of its t, which is equals to root 3 multiplied by x. My x in this case, it's positive root 3 plus 3, which is this 3 value. Therefore, I'm going to say t. Sorry about that. I'm going to say t is equals to root 3 multiplied by root 3. In this case, it's going to be 3 plus positive 3. And therefore, when I add these two together, I get that my value of t in this case is equals to 6. And therefore, we managed to solve question number 3.6. Okay, that's how we solve it. Therefore, we move to the last question, which is 3.7. Now, 3.7 is going to be, it's a little bit tricky, guys. So I don't know if, let me use this part or let me use this one. So 3.7, we move to 3.7. So 3.7, it says to us determine the area of triangle ABD for 5 marks. This is a lot. Just know that when you have 5 marks in analytical geometry, you're going to have to work hard. So that means to determine the area of ABD, A, B, you see, D, not AED, guys, ABD. That means we're talking about this angle. Oh my God, I hope I connect them properly. Oh my God, you see, this is what I hate about my handwriting. Okay, so that's a triangle we're talking about. So they want us to determine the area of this triangle, which is ABD, A, B, and D, okay? So now this is what I have learned. This is what I've taught you, if I remember. I said to you, there are many different types of triangles. We have right angle triangle. Right angle triangle is a triangle that looks like this, whereby it has 90 degrees in it. So when they say to you, determine the area of this triangle, you're just gonna say, oh, area of this triangle, it is half base multiplied by height. But if I give you, maybe let's say an isosceles triangle, or I give you a scalene triangle, or I give you equilateral triangle, and I say determine the area of these triangles, you're not going to use this formula. You're not going to use half base multiplied by height to determine the areas of these triangles, because there is literally no height here. These triangles, it is true, they have heights, but in this case, there is no height that acts perpendicular to the base. So now in that case, we're not going to be able to use this formula to determine the area of these triangles. Therefore, what formula are we going to use to determine the area of these triangles? We're going to use the area rule, okay? The area rule is one of the formula or formulas that we're going to use to determine the area of these triangles. Now, in this case, there is no 90 degrees. You don't see 90 degrees. And in maths, you don't assume unless if you are told, or unless if you have proven, or there is a 90 degrees in this triangle. There is no 90 degrees. So that means you're going to have to use area rule. So now, how are you going to use an area rule to determine the area of this triangle? Now, remember, let me remind you or refresh your brain. Let me jog your brain. So if you're given a triangle like this, right, and you want to determine the area of this triangle. So let's say this is point A, this is point B, and this is point C. To determine the area of this triangle, you're going to say area of this triangle by using area rule. You must be given, or you must know one of the angles, one of the magnitude of the angles. Let's say you know the magnitude of this angle. So if you know the magnitude of this angle, you're supposed to use these adjacent sides. That means you're going to say half multiplied by BA multiply by BC sine angle B. This is the area rule that you can use. If you know the magnitude of these angles, you can utilize the magnitude of these two adjacent sides to these angles. These adjacent sides are adjacent to the angle that we are going to use to determine the area of the whole triangle. So that means in this case, to determine the area of this triangle, we know the magnitude of beta. We have just calculated beta, question number 3.4. So that means we're going to have to determine side AB. We're also going to have to determine side AD. And when you know the magnitude of AB, and when you know the magnitude of AD, we know the magnitude of angle beta, we can determine the area of this triangle. So now, how are we going to determine side AD? We use distance formula, obvious. But now, do we have point EA? Yes, we can determine point A. We have the equation of AB. A, it is the x-intercept. That means y value at this position. Okay, so here we don't know the value of x, but we know the value of y with 0. That means we're going to have to determine x first. After determining x, we use distance formula to determine AB. Same applies to D. D, we know that Lorna, it is the x-intercept. We don't know the value of x, but we know that the value of D, the value of y for D, is 0. And therefore, we determine the value of T in this case that is equals to T, which is here. So that means we're going to use distance formula once more again to determine what? Sorry, to determine this side AD, not this one. I'm making mistake. So to determine side AD, we're going to use we know the equation. Do we know the equation? Yes, we know the equation of CD. We're gonna determine D, which is y x-intercept, and therefore we determine AD. After determining AD and AE, therefore we know beta. We have less than 1 minute.